Let's go to page 33 and start with number 44. So let's read through. So this is the job problem. Okay, so you can go ahead and put in a table to organize the information. So a man and a son doing the job. Okay, so this is the time and this is the rate. So the man can do a job in 9 days and the son can do the same job in 16 days. So the rate would be 1/9. So it means every day he will finish 1/9 and the son will finish 1/16. Okay, so now let's go ahead and translate the equation. Is that they start working together. So it'll be 1/9 plus 1/16. So they're working together up to 4 days. So they win for 4 days. After that, the son leaves and the father finishes the job alone. So it'll be 1/9 times X number of days, and this will finish one job. So again, 1 means 100% of the job. So let's go and simplify this. Okay, so I'm going to multiply this thing. I'm going to distribute. So I get 4/9 plus 1/4 plus 1/9x equal to 1. And adding this together, I get 25/36 plus 1/9x equal to 1. Go ahead and minus 25/36. So 1/9x equal to 11/36. Then multiply by 9. So x equal to 11/4. So x would be equal to 2 3/4 days. Okay, let's go to 45. Okay, number 45 is similar. Okay, so 25 women did 1/5 of a job in 8 days. Okay, so there are 25 women times by the rate. So the rate would be 1/x. So 25 women times the rate, how fast they're doing, and for 8 days, and this will equal to 1/5 of the job. And so first I'm going to figure out the x. X is how long it will take one woman to do the job by herself to complete the job. Okay, so I'm going to move the x over. So I got 25 times 8 equal to x/5. I multiply both sides by x. Then I'm going to multiply by 5. So multiply by 5. So this is multiplied by x and multiplied by 5. So this will be gone, and so this will give me 1,000. Okay. So once I find x equal to 1,000, then I will know the rate. Okay. So now let's go ahead and read the next part. It says, how many additional... Okay, so now because of emergency, it becomes necessary to complete the job in next 20 days. How many additional women need to add it to the group of 25 to complete this? Okay, so you start with 25 people. Now you have to add, I'm going to call it n. Okay, so you have to add more people. And the rate is 1/1,000. Then you have to times it by, you have to finish the job in 20 days. So times by 20 days equal to 4/5. Okay, now the reason it's 4/5 because they already did 1/5 of the job already. So they got 4/5 of the job left. Okay, so first I'm going to multiply 1,000. So I get 25 plus n times 20 equal to 800. Then I'm going to divide it by 20. So 25 plus n equal to 40. So minus 25 minus 25. So n equal to 15. So need hire additional 15 women. Okay, let's go to number 46. Okay, so number 46. Two cyclists are 7/8 of the way through a mile-long tunnel. So they're over here. And when the train approached the close end at 40 miles, so the train is coming at 40 miles per hour. And the riders take off at the same speed in the opposite direction. So one going this way, one going this way. And how fast did they ride? So looking for the rate. Okay, so this is, so they are 7/8 of the way. Okay, so what we're going to do is we're gonna kind of fast forward to when the moment that this cyclist just escaped the tunnel and the train is right over here. So basically, we end up with this situation. The train is right over here. Okay. Now, because they're going at the same speed, so if this is going 1/8, this person going 1/8 also right over here. So this person is going to be right over here. So that means this is going to be, so this is 1/8, this is 1/8, and this would be 6/8, okay, of miles. And the train is 40 miles per hour. So now the cyclist is over here, he's going over here, and the train is going to go this way. Okay. So you can, using the formula, the R times time equal to distance. So I'm going to do the cyclist. Okay, so the cyclist, the rate, you don't know, so I'm going to call it X. And the time, don't know, and equal to 3/4. Now for the train, the rate we know is 40. The time, we don't know, so it'd be T, and the distance is 1 mile. Okay, so again, it's 40 miles per hour. The time we don't know, and it's 1 mile. Okay, so over here we can go and substitute the T into here, then we can find X. So T equal to 1/40, then we can substitute this into here. So times it by 40. So X equal to 30/4. Oh wait, times by 40. So it'd be 30. Miles per hour. Okay, let's go to number 47. Okay, the 47, a train X meters long travels at constant speed and take 20 seconds from the time it enters a tunnel 300 meters long, so the tunnel is over here. And it exit over here. So it takes, and the time would be 20 seconds. Okay. Okay, now it says one of the stationary seating light in the tunnel is directly above the train for 10 seconds. So let's put a light anywhere. So let's say, let's say if there's a light over here, okay? So since the time is 10 seconds, and use the R times time equal to distance. So just from physics, okay, imagine that, so again, the light's over here, so train's passing through, so it takes 10 seconds to go across. Okay, so you're gonna have a R times time, the 10 seconds will equal to the distance. Okay. In this case, it's the X. Okay, because it take the train. So the train of the speed take 10 seconds to get the entire length of the train across that light. Then you have another equation right over here. So the rate of the train times time, 20 seconds, will equal to the distance. Now, notice from here, and it's going to end up right over here. So the distance from here to here is x plus 300. Okay, so now it's just a matter of solving this. So since this is an easy equation, we're gonna move this one first. Okay, so R equal to x over 10, and I'm gonna substitute into here. And this one cancel out, so you got 2x equal to x plus 300, and so minus x on both sides. So x equal to 300 meters. So the length of the train is 300 meters. Okay, let's go to number 48. Okay, so this one you have a circular track. So you have two scenarios. So first scenario is when you have one person running this way, one person running this way. And I'm going to call this one this person running at a rate of x, and I'm going to call this at y. And so over here, if they're running in the opposite direction, they meet in 6 minutes. So that means, so think about, so they're going like this. So that means the speed, the distance they travel is combination of the two. So you can use R times time equal to distance. So you have a x plus y, that's the rate, times the time, 6 minutes. And the distance, I'm just called the one circumference, okay, 1. Okay, so 1 circumference. Now over here, they're going in the same direction. Okay, I'm going to call this, this is x, and this is y. So now notice the distance, you have to use, so it's going to, distance is going to be the difference between the two. So it's going to keep going, and they're going to eventually overlap. So just go ahead and think of that way. So you're going to have the difference of the speed. The difference between the two speed will be x minus y, and times it by 1 hour, 60 minutes, and this will equal to 1 lap. Because after all this time, the distance between it is 1 lap. Okay. Okay. So notice you get x plus y, x minus y. So the y is already opposite. So it's easy. Just go and just get rid of the number. And then you put underneath. Go and add. Divide by 2. Okay, but you're looking for, so x is a faster person, and you're looking for the slower one. So it's looking for y. So I'm going to use this one here. So minus 11 over 120. Okay, but this is the miles. This is the miles per minute. So you have to be careful. They ask for miles per hour. So you need to multiply by, so you have to get rid of the minutes. You have to put 60 minutes up here. 1 hour. So that's how you get the hour down here. So to get rid of that. Okay, so y, so they cancel out. So you're going to get 4.5 miles per hour. Okay, let's go to number 49. Okay, so this is the same type of what we have before. So this is the job problem. Okay, so a crew of 30 people can build a certain road in 60 days. So it's going to be 1 over, I'm going to call this x. Okay, so this is the rate, 1 over x in 60 days times 60 equal to 1 job. Okay, so I'm going to find out the x first. Okay, so move the x over, so x equal to 1800. Okay. So if a person work by himself, it would take 1800 days to finish the job by himself. Okay, so now let's go back to the problem. It says after 10 days. Okay, so now you have 30 people times 1 over 1800 times the rate, and after 10 days, so times by 10. So after 10 days, there's a change. Okay, the company want to build a road in 30 days, not 60 days. So how many more people must be hired? Okay, so now you have to add more people now. So this is the first stage. So now there's a change. So you have to do the 30 plus additional number of people times 1 over 1800. Okay, and you have to times it by. Okay, so now instead of 60 days, you have to build in 30 days. So you use up 10 days, so you got 20 days left. Okay, so again, so after 10 days, you need to hire people and to finish the job in 20 days, and this will equal to 1 job. Okay, so now I can go and work through this. So multiply this together, this will equal to 1 over 6. And I'm going to cancel these things out. Okay, I'm going to minus this over here. So I got 30 plus n times 1 over 90 equal to 5 over 6. And go ahead and multiply by 90. I got 30 plus n equal to 75 minus 30 minus 30. So n equal to 45. So you need to hire additional 45 people to be able to finish the job early.